Hello everyone, welcome to Probability and Statistics for Data Science. In this lecture, we are going to learn some very important basic concepts in a simple and easy way. Even if you are new to the subjects, don't worry at all. I will explain everything step by step with a simple examples so that you can understand clearly. So let us learn. So today's topic is expectations and variances of random variables. These may sound like different words and difficult words, but they are actually simple ideas. So expectation means the average value we expect from an experiment. Variance tells us how much the values change or spread out. So these concepts are very useful in our day-to-day life, especially in decision making and data science. So let us look at this simple example. Imagine two boxes. Each box contains cinnamon and ginger candies in different numbers. We randomly pick one box and then pick a candy. Now we are interested in finding probabilities based on what we observed. This type of problem helps us understand how probability works when there are multiple steps involved. So here total candies in box B1 is 11 and in box B2 is 13. In B1 the number of cinnamon candies is 7 and the number of ginger candies is 4. Similarly as in B2 cinnamon candies is 3 and the number of ginger candies is 10. So here in this problem we define events clearly. Event A means we selected a cinnamon candy. Event B1 means we choose box 1 and B2 means we choose box 2. Defining events like this helps us organize the problem. So once we define clearly the events, solving probability problems becomes much easier. So then conditional probability. So probability of A given B1 is 7 by 11. Probability of A given B2 is 3 by 13. Probability given that B1 is equal to 1 by 3 and probability of B2 is equal to 2 by 3. So now we calculate something important. We want to find the probability that the candy from the box 1 given that it is cinnamon. So this is called conditional probability. We use Bayes' theorem to solve this. So probability of B1 given A is equal to 7 by 13. We have calculated from the formula and we are solving. So now let us look at another real life example. A factory uses 3 machines to produce items. Each machine produces a different percentage of items and each machine has a different defect rate. Our goal here is to find how many defective items were produced overall. So this is a practical problem used in industries. So we have to find the probability that the defective is from machine 1 and what fraction of the total output is defective. As the question is given in percentage, we are converting into the probability values to lie between 0 and 1. So the probability of A, B and C, that is produced by 3 machines, is probability of A is equal to 0.5 and probability of B is equal to 0.3 and probability of C is equal to 0.2. So let D be the event getting a defective. The percentage of defective output of these machines are 3%, 4% and 5% respectively. Then the probability of D given A is 0.03, probability of D given B is 0.04, probability of D given C is equal to 0.05. So to find the total defective probability, we combine information from all the machines. We multiply the probability of choosing each machine with its defect rate and then add all these results in probability of D. So this gives us the overall probability of getting a defective item, so which is 0.037. Now we go one step further. So if we know an item is defective, we want to find which machine produced it. So this again uses conditional probability. So we are finding probability of A given D. So this helps us identify the source of the problem, and we are solving probability of A given D as 0.405. So this concept is very useful in quality checking and fault detections. The next topic is random variable. A random variable is simply a number that represents the outcome of an random experiment. For example, when we roll a dice, the result can be 1, 2, 3, 4, 5 or 6. Instead of writing all the outcomes, we use a variable like x to represent them to make analysis easier. So this is called random variable. Each value of a problem in a random variable has a probability. For example, when rolling a fair dice, each number has the same probability, which is 1 by 6. One important rule is that the total of all the probabilities must always equal to 1. This is the very important condition in probability. The next one is discrete random variable. A discrete random variable takes specific countable values like 0, 1, 2 and so on. Examples include the number of students, number of defects or number of calls received. So these are easy to handle because we can list all the possible values. So the examples are as follows: the number of children in a family, Friday night attendance in a cinema, the number of patients in a doctor's surgery, the number of defective light bulbs in a box of 10. So these are the countable number of distinct values. So the next topic, we move to discrete probability functions. So when x is a discrete random variable, suppose that the possible values that it can assume are given by x1, x2, x3 which are arranged in some order. Suppose all these values are assumed with probabilities given by p of x equal to xk, which equals f of xk for all k values are 1, 2 and so on. So it is convenient to introduce probability function. So this probability function is also called as the probability distribution, where p of x equal to x is equal to f of x. So for x equal to xk, this equation reduces for other values of x given that f of x equal to 0. So in general, the probability function satisfies two cases: that the total probability is always equal to 1 and the value of f of x is always greater than or equal to 0. The next definition is discrete cumulative distributive function or CDF. Fx of a discrete random variable x is defined by fx of x is equal to probability of x less than or equal to x, where x belongs to a real number. It satisfies the condition, that is the connection between capital Fx and small fx is that capital Fx of x equal to summation over xi less than or equal to x for all fx of xi, if and only if small fx of xi is the difference between xi minus 1 and xi in a cumulative distributive function capital Fx of x for all I is equal to 1, 2, 3 and so on. So now we have understood what random variables are. So we shall start applying these concepts to solve the problems. So remember, when every random variable must have probabilities assigned to each values, and all these probabilities must always add up to 1, which is a very basic rule you should never forget. Then These are the properties of discrete cumulative distributive function. So when the limit values of x tends to minus infinity, CDF is 0, and when x tends to plus infinity, the CDF value is equal to 1. So fx is non-decreasing means then fx of a is always less than or equal to fx of b whenever a is less than b, and the probability of value x, which when it lies between a and b, is given by the difference of a and b in a cumulative distributive function fx. So now we are given values of x and their probabilities. So if we want the probability of multiple values, we simply add them. For example, probability of x being 2 or 3 is sum of their probabilities. So this is how we work with the probability tables. Now consider tossing a coin twice. The possible outcomes are head-head, head-tail, tail-head and tail-tail. We define a random variable as the number of heads. Now we count how many heads appear in each outcome. We are counting here, and after counting we assign probabilities to each values of x. So this gives us something called a probability distribution. So it tells us how likely each value is. So the probability distribution of x and f of x is as follows here in this table. Given k value by 1 by 10, and let us solve the second question here. So probability of 1.5 less than x less than 4.5 given x greater than 2. So here we know that the conditional probability P of A given B is equal to probability of A intersection B divided by probability of B. So the denominator denotes the probability of B, and the numerator here it is nothing but the probability of A. So as per the formula, we have to calculate probability of A intersection B, that is the probability of 1.5 less than x less than 4.5 intersection x greater than 2 divided by P of x greater than 2. So the intersection between these two values are 3 and 4. So let us look at P of B. So when x value is greater than 2, we look for 3, 4, 5, 6, 7, and when it is for A, probability of x lies between the value 1.5 and 4.5. So obviously we can take 2, 3, 4, and to find the intersection, the value must be greater than 2. So obviously then P of x equal to 3 and P of x equal to 4 comes, divided by P of x is greater than 2. So obviously then 3, 4, 5, 6, 7 take up the values, and when we add all those, we will be getting the answer as 5 by 7. So the next problem, this is another one practice problem. So practice this by your own, follow the same steps carefully. So as of practice only, we can improve the understanding of these probability concepts very well. So this is another one practice problem. To strengthen your knowledge further, always go step by step and avoid skipping the calculation parts. So check your final answer. Make sure the probabilities are correct and the total probability values equals to 1. This is a comprehensive problem where you apply all the concepts you have learned so far. So take your time and solve this question very carefully. See, all the concepts which we have learned before will be used in same single problem itself. Work through the solution step by step to avoid mistakes and to build confidence. Now you have learned about random variables and probability distributions. Keep practicing these concepts regularly. So only with practice, probability becomes very easy and interesting. See you in the next session. Thank you. Thank you for listening.